Part B, total distance. And I just need more paper, and I have it right here handy. Okay, so in order to find the displacement, what is the displacement? So let's suppose a particle starts moving here at time 0 and ends here at time 3. This is the displacement. On that given interval. Now, it can do this. It doesn't matter. This is the displacement. Where it starts and where it ends. That's the distance between the initial point and the end point. We don't care. We're not talking about the total distance. It can go back and forth, I don't know, 10 times. But if it starts here and ends here, this is a displacement between time 0 and time 3. Okay, we also know that the velocity is given in meters per second, they say. Okay, so let's find displacement. This is nothing else but the integral from 0 to 3 from v of t dt. Of course, no integral can miss dt or dx or okay. So then we have the integral from 0 to 3 from 3t minus 5 dt. And we know how to determine the antiderivative. So this is 3t squared over 2 minus 5t. Because when I differentiate this function, I get 3t. When I differentiate this function, I get negative 5. And of course, 0 to 3. I love it because when I plug in 0, I don't have anything. So I can only plug in 3 minus when I plug in the lower limit is 0. So 9 divided by 2 minus 15. So 27 divided by 2 minus 15 is a negative 30. Negative 3 divided by 2. That really says that the particle goes this way. It starts somewhere here and it goes to the left negative 1.5 meters. That's all it means. Now, when we talk about part B, which is the total distance, that's a different story. And we've done this before with the particle in chapter 2. This is the integral from 0 to 3, because that's our interval, but from the absolute value of v of t dt, which takes into account everything. And the direction of the particle, which goes left and right, whatever, but it's adding distance all the time. If it goes this way or this way, it doesn't matter. It's adding the distance all the time. But first, I have to find this. We couldn't do this in chapter 2 because we didn't know what integrals were at that time. Okay, so we have 3t minus 5 in absolute value. And yes, as we know, there are two possibilities. One possibility is 3t minus 5, and the other possibility is the opposite of 3t minus 5, which is 3t plus 5. But this is very important, and I will never solve this one, ever. I will only solve this one. So this is 3t minus 5 strictly greater than or equal to 0, which means t greater than or equal to 5/3. Here, I only copy the opposite, less than 5/3. If this one is less than 5/3, then this one is greater than. It doesn't matter where you put the equal symbol, but not twice, either here or here. So now, when I try to determine this integral for finding the total distance, then I get, by the properties of the definite integrals, from 0 to 3. Well, 5/3 is between 0 and 3. So between 0 and 5/3 from this, and between between 0 and 5/3 from this, and 5/3 and 3 from that. 0 to 5/3 from this one. Don't forget dt. And from 5/3 to 3 for greater than or equal to 5/3 from this one. 3t minus 5 dt. Okay, I know the drill. That's negative 3t squared over 2 plus 5t, but this time from 0 to 5/3 plus 3t squared over 2 minus 5t, but from 5/3 to 3. Let me stop for a moment. Please ask if you have any questions so far. Anyone, any questions?
I have a quick question.
Yes, please.
Can you go over how you got that derivative part of negative 3t squared divided by 2? You just did. Yep.
Yes. So it's from the rule that if I want to find a function whose derivative is t, I have to increase the power of t by 1 and divide by the same number.
Right.
Because when I bring the, that's okay. I know you haven't gotten the chance to look at this because we had the test yesterday from something else. I know that. So I bring 2 down, I simplify, and that's how I get the t. So it's just going backwards. So when I differentiate this, I get t. When I differentiate this, I get 5. Better?
Yes, thank you very much.
Thank you. Okay, so then I plug in 5/3. So I have negative 3/2 times 5/3 squared, which is 25 over 9. And plus, I plug this in and I get 25 over 3. I'm happy when I plug in 0 is nothing. Plus, I have to plug in 3. So 3 times 9 over 2 minus 15. But be very careful now because now I have to subtract when I plug in 5/3. So I have 3/2 times 25 over 9 and minus 25 over 3. And don't expect these to cancel because they do not. Okay. Okay, so we have here negative 75 over 18 plus 25. So 25. I lost my whiteout. So I want to simplify. I want 25. Maybe I should just not write anything here and just continue on the next page, not to confuse anyone. Okay. So I simplified and I get negative 25 over 6 plus 25 over 3 plus 27 over 2 minus 15 minus, again I have the same thing, minus 25 over 6 plus 25 over 3. Okay. So when I add these two, I get negative 50 over 6, which is negative 25 over 3. So then these will cancel out. Because when I add here, I have negative 50 over 6 or negative 25 over 3, which will cancel with that. I still have a positive 25 over 3 plus 27 divided by 2 minus 15. Times 2, times 3, and times 6. So 50 plus, I think it's 81, yes, minus 80, right? Minus 90. 30, 0, yeah. Okay, so this is negative 9, 50 minus 9, 41 over 6. This is the total of course in meters, total distance covered by the particle between 0 and 3. So 6.5 or 6 meters and 5/6 of a meter. Almost 7 meters covered in between 0 and 3. And this is the law of net change. And I don't have anything else to say. Unless you want other examples or anything. I'd like us to go back to WebAssign and just choose problems. I want to help you, give you a boost on each and every section from 4.9 through, I put the book away, from 4.9 through 5.5. Anything. Anything you'd like to continue with. I want to help you with that. Anything. So we can get a push forward. Anyone would like to start by choosing anything? Is anyone there? Anyone?
I'm here. I'm looking through
Very good.
WebAssign.
Okay, very good. Thank you. Anything you'd like. It's your chance to get your homework done.
I have another question.
Yes.
It is from section 4.9.
4.9.
Derivatives.
Yes.
It is find f. So f prime of x equals 1 divided by the square root of 1 minus x to the second.
Like this?
Correct.
Very good.
And then it says f of 1/2 equals 6.
Like this?
Yes.
Excellent. So if the notation is f prime, I know it doesn't make any difference because you're just plugging the entire function in there, but the notation, if we're given f prime, then we are really finding f of x. If I'm given f of x, I'm really finding f of x. But since I'm given f prime, so when I'm given f prime, I will find f of x. Notation for notation purposes. Okay, so now I'm asking myself, okay, so what function, of course plus a constant c, will have a derivative that is that? Is there any function that I can think of that when I differentiate all this, I get that? So let's think for a moment. We've seen this function before. Which function is that?
So it's arcsine.
Very good.
Line.
Is that clear? So this will be arc sine x. Because when I differentiate arc sine x, I get 1 over the square root of 1 minus x squared. Plus a constant c. But I am given this condition that will solve the problem with c. So then, f of 1/2 is 6. So I plug in arc sine of 1/2 plus c equals 6. And now I have to remember which angle has sine 1/2. And I know that that angle must be
Pi over 6.
yes. Very good. This was part 3, May the 4th. Okay. No, it's not for kids. Please. Yes. Okay, it's doing its thing now. Yes. So it is indeed pi over 6 plus a constant c equals 6. I have to subtract. c equals 6 minus pi over 6. I don't know how they want it, but you can enter it like this. That's good enough. Or for me, this will be good enough. Or this. But you don't enter this. I'm sorry. So you have to enter the function. So f of x equals arc sine x plus 36 minus pi over 6. This is what we have to enter. Any questions? Any questions? Anyone?
Just a quick moment to look over all the sections.
Very
and then-
good. Oh, I'm waiting. That's fine. No, I'm not going anywhere. Promise.
Yeah, there's an application one at the end of
Yes.
4.9.
Yes.
It
Any
says-
questions on this one? Are we done with that?
Oh, I didn't have any questions.
Okay. Everyone okay? This is okay?
Yeah, I'm good on it. Thank you.
Okay. Perfect. Yes, I'm ready.
Okay. So it says a stone is dropped from the upper observation deck of a tower 50 meters above the ground. I'm sorry, did you get that?
Yes. So I'm expecting a function, right?
Yeah. So it says assume that gravity equals 9.8 meters per second squared, and then so find the distance. Part A is find the distance in meters of the stone above ground level at time t.
So we're not given any function?
No. So it just says h of t,
So which
It
problem are we
equals-
looking at? Or
and then we enter the
which-
function.
which section is that?
That's 4.9. For me, it's number 18.
Okay. Let me just see
Yeah.
if I can read it from here. 4.9 view. Okay, I'm viewing. Number 18.
Yeah, I think it's just kind of like walking you through it. So 50, because 50 would be the starting point, and then it would be falling at a rate of 9.8 meters per second squared.
Okay, so they're not giving us other than the gravitational acceleration, right, which is 9.8 meters per second squared, and they're telling us that a stone is dropped from the upper observation deck. I see it. You have 200. I have 200. Do you have something else? It doesn't matter.
I had 50, but it
50.
doesn't really
That's
matter.
fine. That's fine. So it's from 50 meters above the ground. Find the distance in meters of the stone above ground level at time t. So we are really asked to find an equation. And I just want to point out that in the book, if you have your book handy, they are models, and in which we are given. So I'm just looking for. It's on page. If you have page 347. They're not giving any examples, however, in this section. They're not giving examples of the motion model, but we have to come up with it, especially if that's a problem in there. Okay. I thought I was going to direct you to an example in the book, but I don't see one. Okay. So in order to determine, because they are asking us to find the distance, so the distance is s of t. But in order to find the distance, we have to come up with a velocity. So once we have the velocity, then S of t will be very easy to determine. Okay, so the velocity for something like this, it comes from physics. So the velocity is, I'm thinking for a second, it's negative g t, because this will be gt squared over 2, gt. Yeah, that is for a free falling object. Thank you for bringing this this up. Thank you. Free falling object. If you do not, assuming you do not give it a push, so it's just something like this. Oh, if I force it up or down, it's a different story. But if you just a free falling object, that's the velocity. So replacing the velocity in here, but again, this is coming from physics. So this is the integral from negative gt dt. Negative g is just a constant, right? But what function prime is t? It's t squared over 2, and of course plus a constant c. I replace now g, which is given to us an approximation 9.8 t squared over 2 plus a constant c. Of course, I will divide and get negative 4.9 t squared plus a constant c. But we are told, where is it? We are told that initially, in other words, I dropped it from 50 meters. So we are told that S of 0 is 50. So the initial height, I have the stone right here, the initial height is 50. So at time 0, 50. And that will enable us to determine this. So negative 4.9, I shouldn't even write it, times 0 plus c equals 50. And that's clear that now the distance function will be negative 4.9 t squared plus 50. But again, they should have given this to us. The free falling object model. They're not. And it's not even in the book. I just wanted to point out, direct you to the right, point out a problem or an example, but there isn't one. Okay, now how long does it take the stone to reach the ground, right? So in other words, when the distance is 0, it reaches the ground